34 says add and simplify. Okay? A couple ways to do this. One way is you can do it in the calculator. You can type in this entire original function and get the crazy decimal. Okay? Then type in option A, see if it's the same crazy irrational decimal. If it's not, go to option B. If it's not, go to option C. And option C, you would see would be the exact same ugly decimal. But this is also a pretty easy problem to do by hand. We've got to first simplify these to see if we can add them together. Well, 12 simplifies by breaking into 2 and 6, which is 2 and 3. I'm going to go ahead and write down that very first one. It didn't change. Sorry, I should have done that first. But this 2 pops out, slams into that 3, and they multiply. Our leaf that we left behind was a 3. This is our factor tree, so we left the little leaf laying on the ground. Okay? For 8, we break that up into 2 and 4, which breaks up into 2 and 2. We got our 2's to come out and slam in to be a -6. And again, our tree left a little leaf on the ground, which is square root of 2. Now, as far as simplifying the originals has gone, we're done. But we have to add these together. And to add them, we have to have like terms. Okay? The radicals act kind of like variables. If the variables are the same, they're like terms. Well, if the radicals inside the radicals are the same, they're like terms. So we have like terms here and here. This middle one doesn't have any like term, because there's no one there to combine with it. Well, when I combine them, just like if these were variables, I just combine the numbers out front. -3 minus 6. That's -9 on the square root of 2. The square root of 2 stayed just the same. Nothing combined with this 6 square root of 3 piece, so it sits just there the same, or sits there just like it was, and we get option C. Number 35, more radical work, okay? This is a distribution of a radical because we've got a binomial in here that cannot combine and a multiplier outside. So that's got to go into both pieces. Now I'll remind you, the mantra for how we multiply radicals is we do outside numbers times outside numbers and inside numbers times inside numbers. Now that doesn't mean with the parentheses, that means on the radicals themselves. That doesn't really come into play in this problem. The only numbers we have are inside the radicals. So we go ahead and just multiply via distribution what's inside the radicals. Square root of 15 times square root of 3. That is square root of 45 because it's 15 times 3. Square root of 15 times square root of 5 is square root of 75. Notice the plus sign just dropped back down. It's plus and plus. If you go to throw this in your calculator, you can do it that way by checking the crazy decimals for the same. I'll probably do that on this problem just to show you what I mean. But to do this by hand, 45 will break down into 5 and 9, which is 3 and 3. That's going to be 3 on the square root of 5 because we left that little leaf behind. 15 breaks down into 5 and 15, basically what I just multiplied to get it, which is 5 and 3. Pair of 5s comes out, leaving a leaf of 3 behind. And those won't combine. Please do not combine those tomorrow, guys. Please don't. If the radical isn't the same, they cannot be added or subtracted. Okay? So it leaves us with option B. What does Mr. Sorrell mean when he keeps saying you can put it in the calculator and check the ugly decimal? Let's take a look. Well, if I do square root of 15, and then I open up a new set of parentheses, I've got square root of 3. So I want it to look just the same. Plus square root of 5. Close those off. I get this big ugly decimal. Okay? I get this big ugly decimal. 15.36845. That should be enough. 15.36845. It's going to go on forever and it's never going to repeat. I just picked the place to cut it off. Okay? We would test option A. If we go to plug option A in, option A is 4 plus 4 on the square root of 5. So this is me doing this problem without doing any of this work I did in green. Well, I plugged in option A. It's not the exact same, which means it's not the multiplied, simplified version of this. Okay? Didn't work. I plug in option B. Option B was 3 on the square root of 5 plus 5 on the square root of 3. You can do this from the get-go, or you can do it like I'm doing now to check your answer. This is what I think the answer is, and if it's the right answer, it should match this ugly decimal. And it does, down to the T. It matches it perfectly. So B is in fact our answer. We checked it to make sure. Number 36, this in behavior stuff gives people fits, okay? Gives people fits. And I'm going to just remind you, if they're asking you about in behavior, they're asking you about the ends of a graph. And if they're asking you about a graph, let's look at that graph, okay? 4x squared minus 7x plus 2.5. Zoom 6. I want to know what the ends of the graph are doing. Our graph is f of x. Really, we probably should change this to match it. Let's call this f of x just to be safe. I'll try to remember to do that. It's my bad. But if we want it to look like that, or if we have a graph that looks like that, we want to know what are the ends of the graph doing. Okay? The way we've been writing this out was as x approaches negative infinity, y approaches something. As x approaches positive infinity, y approaches something. The x approaching negative infinity just means left as it goes to the left, which is the same as saying as it decreases. This was going to the right, which is the same as saying it increases. So that's all these are saying. As x decreases, as x increases. As x decreases, x increases. Decrease, increase, decrease, increase. So really, these don't have as much to do with it. It's wanting to know, what are the y's doing here? Well, again, on our graph, I can see my arrows would be right up here, and it would say that my graph's going to go up forever and ever and ever. So as we go further left, our y's are increasing, or our function is increasing. As we go further right, our function is increasing. So we're looking for the ones that say that f of x increases and increases. That one's out. This one says increase, or this one says decrease, so that one's out. We're done with A, we're done with B. This one says increase, and it says increase. We're looking for just what the function's doing. Okay, so that one's still in the running. It looks like our right answer. The next one says this one decreases, but this one decreases, says both decrease. That one's definitely out. That would be a parabola that looked like this. That would be decrease, decrease. Remember, our parabolas always agree. It's our other functions that are a bit trickier. Parabolas always agree. Okay? 37 is another really good problem that can be done a lot of different ways. Me personally, when I look at this problem, it jumps off the page to me as being a square root method problem because there's only a quadratic term. There's no x term, no linear term. To do this as a square root problem just means I've got to isolate the x squared piece and then square root both sides. So I've got 2x squared minus 90 equals 0. That's going to be 2x equals 90 because I add 90 to both sides. Positive 90 cancels here and turns up over here. Divide by 2, get x squared equals 45. Square root both sides, get x equals plus or minus the square root of 45, but that answer doesn't show up. And you sit there and go, oh, well, there's positive and negative 45. There's my answer. No, ours is square root of 45. Well, that's because 45, as we saw earlier, right up here on the right-hand side, can break down into 3 on the square root of 5. So what we have is x equals plus or minus 3 on the square root of 5. Now, you can do this one purely in the calculator as well if you're clever. This says solve. Solve means it wants us to find out what we can plug in for our variable to get 0. So it's asking us to find the zeros. And if we want to do that, we can clear this out. We can type in 2x squared minus 90, and we can zoom 6 this and find out where does it equal 0. And you say, oh gosh, those are two really, really weird numbers. I don't know exactly what they are. Let's calculate them. Calculate the 0. I'm calculating the one on the left first. There's the left edge of it. There's the right edge of it. Negative 6.708. That's not pretty. But can you guess why I did that? For anyone doing it in the calculator, they might go, oh yeah, that rounds to -7. There we go, we're done. No. What that is -3 on the square root of 5. Negative 6.708. Okay? The final alternative is because I said we're trying to figure out what we can plug in for x to get 0, you can just take the solutions and plug them in. Plug in 45 here. It's going to get a way bigger number. It's never going to be 0.